Hello, and welcome to our Eurelectric Power Summit plenary session. My name is Ed Jarvis, and I work for Schneider Electric's Power Systems and Services division and in the Thought Leadership Working Group at the T&D Europe Association. I'm here today in lovely Grenoble, France, which has the honor of being recognized by the European Commission as the European Green Capital for 2022. We are at Schneider Electric's Technopole R&D Center at one of the greenest buildings in the world. This is a LEED Platinum certified building. It's the heart of Schneider Electric's medium voltage innovation. Every day, more than 100,000 Schneider Electric employees work to help ensure our customers' success by bringing green and digital technology and services. And in 2021, we're recognized by the Corporate Knights as being the most sustainable company in the world. But what do we do? Well, watch this.
The world is full of people telling you who to believe they are. Well, we thought we'd tell you who we're not. Let's start here. We're not in shipping. We don't make lifts. Seriously, no lifts. We do this. We're good at this. And we make all of these. And even though you'll find us here and here, we don't make energy. We make you save it. And you'll be saving the environment too. Are we an internet company? Well, we connect and power just about everything around you, helping machines talk to each other and to you, making your world more personal. We're seeking out the big questions and answering them honestly. Like, how can we make the most of our energy and resources? Or can we make access to energy and digital basic human rights? We're real people, employees, developers, partners, investors, and inventors, all passionate about doing what's right. We're open, humans of all sorts from all over, learning from each other and about each other. We're not here to save the world. It'll go on with or without us. We're here to be your digital partner for sustainability and efficiency, to ensure life is on everywhere, for everyone, at every moment.
We're here today to talk about the electric decade, what the next 10 years means for electrical distribution grid operators in Europe. We have 4 important topics to cover today. The first is investments, the second, sustainability, the third, resilience, and the fourth, operational efficiency. We have an exciting, dynamic program today with a full spectrum of key stakeholders and decision makers who will together chart the course for the grid of the future. Today, our distinguished panel of guests includes Antonio Cammisecra, Head of Global Infrastructure and Networks for Enel, Stefano Grassi, Head of Cabinet for the European Commissioner for Energy, Kadri Simpson. We also have Christoph Grudler, member of the European Parliament from the Renew Energy Group, as well as Marianne Laigneau, chairman of the Management Board for Enedis, and Jean-Marc Moulin, transmission and distribution vice president for GE Digital's Grid Software. And finally, Jutta Paulus, member of the European Parliament from Group of the Greens and the European Free Alliance. And in addition to our distinguished panel, we have a special guest, Ms. Catharina Sikow-Magny, Director at the European Commission, Head of the Internal Energy Market. But first, let me introduce Frederic Godemel, Executive Vice President of the Power Systems and Services Division at Schneider Electric. He'll be delivering today's keynote, Rewriting the Grid for Our Future Together.
Hello to all. I'm Frederic from Schneider Electric, and I'm very happy to be with you for this Eurelectric Power Summit. Electricity becomes the source of energy and the solution to decarbonize the world of tomorrow. So we'll see how the grid can evolve, how together we can make the grid evolve to be ready for the world of the future, the new electric world with the grid of the future. Let's look first at what we have to achieve. And we have to achieve 3 things at the same time. The first one is more sustainability and more integration at renewable at the point of generation, and more towards the distribution grid. The second thing we have to do is to witness and accompany the transformation of the usage of energy that will be more and more electric. We see it happening as we speak in the world of mobility with the electric car, but we will see it happening more and more into conversion of processes like heating, like industrial processes that will use more and more electricity to be able to decarbonize their processes, and that's a trend that is here to stay for the next 10 years. And last but not least, with this trend, we will see the world of what we call prosumer, producers and consumer. We will see this world developing very strongly. We'll see more demands for having exchanges of energy data between the distribution of those electricity and the usage of those electricity, so that we make it more efficient, more green and more sustainable. All this, of course, is a strong call for digital technology, because this is not possible to cope with those 3 changes simultaneously without more information, more exchange of information. So digital is key in all this transformation. Let's look at what it means for the profession, for the distribution utility that becomes much more at the center of this transformation. The first thing is to continue to accompany the grid with resilience and with sustainability. And that's a very important mission. Obviously, people expect availability of energy. We've seen in some places in the world that when electricity is not there, the world stops, right? The second thing is obviously invest to cope with more electricity demand, but invest very smartly and make those investments more profitable than the one that we did in the past. And the last thing is to be able to have grid code, network code that allow a fair exchange of information between the consumer that becomes prosumer and between the distribution operators. All along that, you see obviously that it's very important to measure and monitor progress. We'll come into a world in which KPI are extremely important for the DSOs, smart indicators, so that we ensure that the grid becomes more sustainable and prepare a better future in terms of decarbonization. Looking at that, let's look at each of those points and where do we stand and where will we be in 10 years from now. Today, we already have a lot of affordable technology to have a more sustainable grid. Obviously, more renewable, we know it. New transformers, new automations that allow to better pilot the grid with less travel, less people-intensive operation. We see as well that thanks to new technology, we are able to replace SF6 on a large part of the network by air solution without using new chemical gas. If we look tomorrow, we should be able to go one step further, which is to work on expanding the lifetime of some of our equipments. Today is around 20-25 years, it can go longer. And to the contrary, being able to spot some equipment that are more sensitive, where there is more solicitation, and being able with analytics and data to adapt the policy of replacement of equipment. We need as well to be able to develop circular economy, means having more retrofit, more reuse of what we are replacing, because we know we cannot permanently consume more and more new sources of products and raw material. Let's look at another point, which is the resilience. Resilience is very important. We saw with the pandemic, we had a stress test, I would say, on resilience of the grid. It went well in most of the geographies, especially in Europe, but we have to keep doing that and keep watching at the resilience. A lot of technologies are available today. I could speak about distribution management system with a lot of software power that is allowed to permanently optimize the grid, but we can look as well at the world of tomorrow with more advanced software, more data lakes, so that we can predict permanently and simulate what will happen with the grid so that we can play some scenario. We know that storm and tough weather are something that is very important to cope with, and we need to be able to prepare our grid with more simulation so that we play scenarios that are able to optimize the grid even in very tough conditions. Along all this, cybersecurity is extremely important, and we are ready together to work on this challenge to ensure that the grid is completely cyber secure. Let's go into investments. More electricity means more investment. We could do those investments like we did in the past, a lot of hardware. We can mix more those investments with a fair dose of software. Software allows to dynamically simulate the grid, to dynamically simulate the level of investment so that we permanently challenge hardware investment compared to more dose of software, more dose of automation, and a more optimized grid. Last but not least, exchanging with the user, reshaping the network code so that we are able to go in a world in which people are looking at how they use and when they use electricity. Electricity will become core for many of us. Electrical vehicle is an example. It will not be possible to charge electrical vehicle at scale during peak hours. So we need to ensure that we have systems that incentivize users for the best source of energy without generating incredible hardware investments that we could not afford collectively as a society. That's the world of tomorrow. My last message will be to call for action now, not in 10 years. We should not wait for the next 10 years to have all this implemented at scale. And especially my last point, which is a much more dynamic commercial exchange of information between the prosumer and the DSO. This world is the world we need to build now so that the grid is ready for the next 10 years. If the grid is ready, electricity will be able to decarbonize the world at scale.
Hello and welcome to our panel discussion at the Eurelectric Power Summit. Thank you very much to our panelists for being here today.
Hello. Hello.
Hello.
How new investment frameworks can unlock innovation and flexibility. We know that new clean technologies can bring benefits to all Europeans, but only if the right policies and investments make it possible. Stakeholder cooperation should let distribution grid operators remodel grid management, integrate more renewables, leverage prosumers, and bring valuable new services to customers. We're lucky today to have some top industry and policy leadership with us. So let's explore the details with our guests. Mr. Grassi, if we could please start with you. Please give us a sense of the policy picture on investments in the power sector.
Thank you, Ed. I think the Commission has always been clear that the Green Deal comes with investment costs and that we need to turn this investment cost into investment opportunities. Last year, immediately after the Green Deal strategy, we adopted a Green Deal investment plan. Since ages ago, it was January 2020, where we assessed the investment challenge at 1 trillion in this decade. And since then, I think the scale of the challenge has become even clearer. In our climate target plan, we assessed that the investment cost to reach minus 55% by 2030 will be 350 billion euro per year until 2030. And this is 90 billion more than reaching the previous target of 40%. And it's, if you only look at the cost of investment in the offshore grid and in the grid needed to connect offshore wind park alone, we are at 530 billion euro by 2050. Now, it's very clear that is an investment challenge of that scale cannot be addressed with public financing alone. And I think the role for policymakers and the role for the Commission there is to give a sense of direction, to set incentives and to set the right regulatory framework to create the right environment for investment to flow. And this we have tried to do in an approach in 4 steps. The first step was indeed to set long-term targets by 2030 and 2050, climate neutrality and minus 55%. Now these are enshrined in the climate law, and this gives an element of predictability, a framework of certainty for investors to know where private capital should flow in the coming years. Second, we have put the green transition at the center of the recovery and resilience plan. There is a clear percentage earmark for green investment, and this will mobilize an unprecedented amount of money for green projects. Third, we have revised and modernized our regulation for 10E, for our infrastructure policy, in order to introduce new categories of projects eligible. And we have a lot on smart grids, both electricity and gas. And we want, through this instrument, to point public investments and private investment complementary into the projects we need to move to the integrated energy systems for 2030 and for 2050. Fourth step, we have just recently adopted the first delegated act on the taxonomy regulation on sustainable finance. This is a groundbreaking exercise. It's the first global benchmark for directing private investment into green financial products. And we hope that by this, we will also help create a category of green bonds, and the Commission itself will be an issuer on the markets through, we need to raise the capital for our next generation Europe. I think after the summer, we will issue around 250 billion euro per year. And this should help also capital to flow to the right investment. So I think step by step, policymakers and the European Union are trying to set the right type of framework and to give the sense of direction for private capital to flow and to help us address this gigantic investment challenge for the Green Deal.
So, following on that picture, if we could ask our guests, Mr. Cammisecra and Mrs. Laigneau from Enel and Enedis, respectively. Maybe we could start with you, Mr. Cammisecra. Given that context, how do you see the use of flexibility impacting your investment strategy? Are you facing barriers with existing EU regulatory environment?
Thank you for your question. I think the 2019 EU directive has been quite clear in assigning a central role to the distribution system operator as a key actor in the new management going forward, in the new management of the distribution systems going forward. So acting more as a system operator. So flexibility, it's from at the same time an opportunity, but also heavy duty than the system operators, the distribution system operator will have to deal with. So from this point of view, envisaging the complexity, the growing complexity of the management of a distribution system operator is crucial in order to address the right investments in the right technology. Some of them are still not already mature, to be used in the new context that is, we believe, in very few years, less than 10 years, for sure, maybe just 5 years, will become mainstream in our systems, especially in the most evolved countries. In large part of the European distribution companies, this will be visible, I think, in a period of 2-3 years. So from this point of view, yes, we are changing our investment paradigm. We are targeting more and more, directing more and more our investments toward digital solutions, integrating what is the digital management of the grids as an infrastructure with the digital technologies that we will need to manage and orchestrate the power flows, but also the flexibility technologies that will be more and more connected directly to the distribution system rather than traditionally only on the transmission system itself. So the short answer is yes, we are changing and evolving our investment strategy in order to habilitate the new technology forms flexibility, but not only to be available in the grids as they will be acquired very soon.
Thank you, Mr. Cammisecra. Mrs. Laigneau, what about Enedis? What is your perspective?
On flexibility, mainly. As Antonio and Stefano just said, I think it's important to keep in mind the huge change regarding the DSO investments for the coming years. We have to deliver a massive level of investment in order to be really the backbone of the energy transition. And I really think that the distribution network is the backbone of the energy transition, because in order to decarbonize economy, you need more uses of electricity. Then you need a more powerful and resilient and digital and bi-directional grid. So we just keep in mind that 2 years ago, all the European DSOs altogether invested 26 billion euros. We deliver a study with Deloitte and the ETSO, which is our European Association of DSOs, and that shows that by 2030, we will have to invest, to double this figure and to invest up to 50 billion euros each year in order to deliver the energy transition. So regarding that amount, of course, flexibility is key, but for the time being, it's, let's say, quite small, but growing problematic. Why is that? All these smart grid projects, DSOs are part of, and especially Enedis in France, have a strong innovation dimension, and mainly and very often flexibility is part of all these demonstrators and international or European or French smart project and smart grid project. So regarding flexibility, we are somewhere between. We've overskipped the research and development phases. We are somewhere between demonstrators and industrialization. So what is key for the future regarding flexibility is to progress towards real industrialization of flexibility. So we worked within Enedis, we worked on the business case. What is flexibility? Yes, for sure, but what for? What could be the flexibility role? And we identified, let's say, 5 main use cases. Flexibility can foster the renewables investment by mutualizing and optimizing the size and of the investment needed to connect new renewables to the grid. That could be the first use at let's say, the perimeter of a region or a community. You can use flexibility in order to anticipate incident on the grid, or when incidents happens in order to fix the problems on the networks. You can use flexibility to have a better program for maintenance and renewable of the réseau. That is number 3. You can use flexibility to postpone investments, and for sure this business case will grow in the future. And you propose to your clients, many renewable producers, let's say, innovative and smart offers, more agile offers to connect them more quickly and, let's say, cheaper for them as well. So flexibility will play a great role in the future. We have the regulation framework for that, and Stefano mentioned that. And the Commission has delivered a directive, and all the states are working in the transposition in the national legislation to provide a stable framework for DSOs. But from my point of view, from my perspective, it's key, but we are at the beginning.
Thank you for that. So, Mr. Godemel, how does technology and services support it? How does it support the flexibility? Are there areas today where technologies are available but underused?
There is a lot of areas today where technologies are used, and I think they were mentioned already in the speech of Stefano, of Antonio, and of Marianne. Technologies are used today, right? And the way to manage a grid that is more flexible, the way to exchange information, the way to optimize investment, technologies are used today. And they work to support since some time already what will become a huge level of investment at the distribution level. And that's the main reason why we develop those technologies at the distribution level, because the complexity is very high. So when we want to balance the grid at distribution, is much more points, is much more complex, and it requires much more use of digital. Are there areas where technologies could help and do better? I see two areas. The first one is around technologies to simulate and plan the investments, right? And execute the investments, especially construction. We see construction as an area where today it's a lot of manual work, and it can be much more automatized, and probably because we face a huge amount of investment, it's more repetitive probably, and it can be optimized. So that's the first area where technology can use. It will be a lot of software that can help to plan and communicate with the operation technology. So we want to be able to build those suites to help utilities, DSOs, to be able to plan better and simulate and integrate with their operation system faster. The second area where technology can help, and it was mentioned, I believe, in the speech of Marianne, is exchange of flexibility data with the consumers. And here, again, we have a lot of experiments, demonstrators, and so on, but today we are not at scale, and that's basically where we have to go, is be able to scale more exchange of information between the consumers that will play a very important and active role in the grid of tomorrow, but that don't want to bother on the other hand. Means they will be active, but they don't necessarily want to take care about it. And that's where technology will help at scale to be able to have cases where flexibility matters almost at the second, without consumer to taking care about it.
Before starting our next session, we wanted to bring you this story from the other side of the world, in Australia. Watch this.
Engineering is not boring and bland as people perceive it to be. It's actually a problem-solving role. My name is Tasnim Abdelrazak, and I'm the Network Control Manager at SA Power Networks. SA Power Networks is the sole electricity distributor in South Australia. We basically have two peak seasons. One is the summer season, which is when your bushfire events creep up. The other component is around autumn. It's at storm events, lightning, rain, wind activity. We have a lot of transient faults, which are basically due to vegetation or animals. And we have hundreds of kilometres of line, over 1.5 million customers. So when we do dispatch crew, they can spend hours travelling to the location and patrolling the lines. The ADMS and the feeder automation scheme is going to give us better visibility of the network because it has smarter reporting capability, and it has allowed us to capture a lot of our network structure to have a centralised source of truth. To be able to restore power to the majority of customers on a feeder in under a minute is something that has never been done in SA Power Networks history. Without Schneider Electric, we probably wouldn't have been able to progress as far as we have and as quickly as we have. It is a very powerful tool. It's a fantastic platform for us just to develop in the future and be the leading edge. in the distribution sector.
How DSOs will stay strong under pressure. We know that for distribution grids, service continuity is about more than just keeping the lights on. It's about business continuity. So facing forces such as climate change, cyber threats, which put pressure on grid operations, DSOs are striving to improve reliability, to limit threats, and to strengthen grid resilience. So let's get some perspective from our guests who are here today. I'd like to please start with Mrs. Laigneau, who leads Enedis. What kind of tools do you use today to support grid resilience? And how do you expect your technology and approach toward grid resilience to change over the next 10 years?
Hello. So I don't know if it's a question about pressure, but it's true that it's huge responsibility for DSO to tackle what is happening now, which is the energy and ecological transitions. So it's about resilience, for sure, for the grids. Why is that? What are the reasons for that? First of all, I think it's about the increase of renewable energy in our, let's say, European energy mix. So we have to answer to that. We have to connect more and more solar and wind energy. For example, in France, for Enedis, we connected 500,000 renewable generation sites in the past 5 years. So this is increasing dramatically. It's a huge acceleration also for self-consumers, and it's increasing a lot as well. It's about new uses of electricity, which implies a stronger resilience from the grids. You know that, electric V, charging, infrastructure, storage, flexibility as well. And it's also resilience because the consumers' habits and behaviors are changing. They are expecting, of course, a high quality of electricity, but also more and more services and new uses. So that leads us, DSOs, to invest a lot, of course, in the resilience of our grids, but also to be able to answer and to be ready when you have extreme climate change events. This is the first type of resilience which are expected from DSOs, to be able to provide quickly electricity when you have outrages or extreme climate crisis. And we know that this will happen more and more. And you can refer to the US recent events, for example, in the Texas or in California. So we have to, of course, to count on technology. You mentioned them, smart meters. In France, Enedis is finishing the deployment of the 35 million of smart meters program. It's also about data, connected tools on the grids in order to monitor in a more precise way our resilience. It's also about solidarity, which is, for me, included in your resilience problematic, and how we need to be close to our territories and to offer the same level and the same quality of distribution networks to, let's say, poor or rich regions within our territories. So it's not only about technology, it's about people as well, about solidarity and tariff conditions as well. But it's true that it's a question of competitiveness for our industrial clients, and that means also our ability to count on innovation and to develop smart meters, smart grids, to offer a higher level of resilience to our clients.
Thank you very much for that perspective. Frederic, Godemel, what about the manufacturer perspective, the technology and service provider perspective?
Well, look, Ed, I'll start it by what Marianne says at the end, and I'll start it by trust, right? Because at the end, DSO are the one fronting the customers, are the one ensuring the resilience of the grid. And what's our mission is to basically ensure they trust the manufacturers, they trust the technologies. And I'll go along with two concepts. The first one is the concept of services, right? It was obviously tested at scale during the pandemic times to ensure that we could be able to supply, we could be able to serve, we could be able to ensure services on some products that sometimes are 10, 20 years old, and that the first part of what matters is that we build trust between technologies and DSOs. They are fronting the customer and they need support in times of stress, in time of pressure, and so on. The second thing is the energy transition and the energy transformation. And what matters here is that electricity becomes much more complex to manage, much more unstable, right, because of renewable, and second, because the usage is different today than what it was 10 years ago, and will be modified significantly. The only way to answer to that is datas. It was said by Marianne with very concrete example, and being able to have datas architecture that understands the world of electricity and that support the usage of electricity all along the chain between production, between distribution, and between usage is extremely important. So that are the two aspects. On all those two aspects, trust matters a lot. Means you need to ensure that those technologies will work at their best and will work over time. That's what matters, and that's the way I would like to complement the answers that Marianne was given.
Thank you, Frederic. Mr. Grassi, what role do you expect regulation to play in ensuring grid resilience?
Thank you, Ed. Can you hear me?
Yes, we can.
Thank you, Ed. No, I heard a lot of recognition from the other speakers of the positive elements of the energy transformation, the decentralization of markets, penetration of renewables, much more players in the market, a higher proportion of energy from variable sources, and integration of systems. And I think resilience can help maximize all these positive elements. But I think that we all have to recognize as well that with this transformation, there are also vulnerabilities emerging, and that there are new pressure points that are becoming more visible, and new threats we must be aware of. And I think we need also an equally strong recognition of these vulnerabilities and possible stress on the grids and on the operators, first of all, among the policymakers. And there are many challenges there which we need to address as policymakers. There is a challenge in terms of resilience of our supply chains and access to raw materials, for instance. There is the challenge of climate adaptation, and the Texas case was already mentioned. Now, I think in Europe, with a risk preparedness regulation, we are a bit better equipped, but certainly it's something we must be very aware of. And we had very recently in the Commission a climate adaptation strategy that addresses also this element. But there is one point I wanted to make today. I think we are still too relaxed, and we are still underestimating too much the risk the cyber threats and hybrid threats can bring to the stability and the functioning of our grids. Just enter in the control room of an offshore wind park, and you will understand the challenge of a cybersecurity threat. Just imagine a situation of pandemic with people working on remote and the risk of cascade effects if we have an interruption of electricity supply. And if you take it from someone who comes from foreign and defense policy, in my previous job, where we have done a lot on hybrid threats, cybersecurity, disinformation, I think we need the same level of attention and action also on the energy in the energy field. Now, the clean energy package leaves us already something to build on, but I think we need to do more. Our commissioner is very alert to this threat. She's participating actively in the Commission work on the security union strategy, and I think we had last year a cybersecurity strategy and an horizontal proposal for the security of critical infrastructure, and I think it's now time to do something energy specific. So we are working now on the network code, on the cybersecurity of cross-border electricity flows, and I think we are planning to present it as soon as possible in 2022, and we are also reflecting on whether to complement the horizontal proposal on security of critical infrastructure, which is now in the interinstitutional negotiation, with something energy specific. So I think we need to be much more aware of the risk and the threats that are coming from digitalization, as well as continuing to work on the upside and the advantages that this is bringing. And I think next year, together with everything on cybersecurity, we will also have an action plan on digitalization of energy services, because I think we need to work on both. Thank you.
Mr. Moulin, you have a transmission and distribution background. What's your perspective?
Well, I can start first with the cybersecurity aspect, and I believe here a little to what Marianne was saying. It's not just technology; it's people, it's processes. Those are the three pillars of cybersecurity, and having a broader adoption of ISO 27001, and then the next elements of the European policy is going to help us be more resilient. The next thing I wanted to say is, as we see the evolution of the role of the DSOs, it's going to be more and more system operation and not just network operator, because as we see the evolution of dynamics, as the grid becomes dynamic, and as the T&D grid is in fact a unique grid interconnected, the TSO-DSO interconnection and how DSO will play an increasing role in the balance and the stability of the grid is going to be key. So some elements of dynamics that today are seen mostly from a transmission perspective are going to be jointly managed with the DSO. And some new technologies such as phasers that will help determine adaptive protection schemes is going to be key for this evolution of this grid managed as a whole in Europe. But if you allow me to take another step back, the other element here is the growing uncertainty. So I think the main element as a provider of solution is the pivots toward agility and time to value. Because as the growing uncertainty is there, we need to be able to adapt faster and bring solution faster, because the DSOs will need solution to bear to fruit faster. So we need the ecosystem to become more agile, so that instead of having new solution coming in 2 years, they can come in 6 months. As the regulation evolves, as the threat come, we will need to adapt, because some of them we know about, some of them we don't yet. So it's about a lot more, not only planning, but also building our capability to respond to change. That's going to determine the resilience of the system as a whole. And that's true for the system providers like us, but I believe it's true for the ecosystem as a whole.
Thank you, Mr. Moulin. It's time to move to the next section. Hello, everyone, and welcome to our session. Let's start our discussion called Sustainability Wish List, How DSOs Will Become Fit for 55. So we expect that DSOs will need to reduce greenhouse gas emissions through technologies that decarbonize, innovations that reduce energy losses, and practices that harness the value of circular economy. But let's hear from our guests. First, I'd like to welcome a special guest, Mrs. Catharina Sikow-Magny, head of Europe's internal energy market. Hello, Mrs. Sikow-Magny. Thank you for being here today. The first question, in terms of electrical distribution networks accommodating distributed energy resources and renewables and Fit for 55, we know that a great deal of investment will be required. But is there enough emphasis on automation and digitization?
Thank you, and good morning, ladies and gentlemen. Very pleased to be here today with you. It is through that smart energy networks, especially a smart electricity grid, will be fundamental in enabling the energy transition to happen. Without the grids, it would be impossible to bring all the resources, decentralized production, etc., to consumers, and to also at the same time benefit from the flexibility potential that is there. So in all our pathways towards climate neutrality, electricity demand is projected to increase significantly, and a large part of this electricity will come from distributed resources. We will see electrification of transport sector, heating and cooling, and also industrial sectors. At the same time, we know that this electricity system will be largely based on variable and distributed renewable electricity generation. So it is even more important to look at how these resources will be connected, and it will be increasingly at low and medium voltage grids. These changes will impact profoundly the design and control of the grids. And here, the distribution system operators will play an increasingly important role at the European level and need to manage their networks more actively. Smart grids, as we call them, is the solution to this. Smart grids need to look at both digitalization and automation at the same time in order to improve grid operations and save costs to consumers. So the green and digital transition, the Green Deal, call for more interconnections, smarter and flexible networks, and integrated energy systems. This all means more digitalization and more automation. The investment needs, as you rightly pointed to, are significant. We have estimated in the order of 60 to 110 billion per year, and this involves a large share of modernization and smartening of our grids. To work more concretely on this important element, we are currently preparing and assessing on what the digitalization means concretely. So we have started working on an action plan, if you wish, on digitalization of the energy sector, where the grids will form an important part. We will lay out in this action plan on the different elements that need to support the work of the system operators and other stakeholders in the energy transition. And of course, our research program will be a big support to this element. So to conclude, I would say that there is sufficient emphasis on digitalization and automation, but of course, more needs to be put in place as we speak. Thanks.
Thank you for that. The next question is about the big focus we see on CO2 and pure decarbonization. But what about sustainability beyond CO2 emissions? What do you think about sustainability at the level of the distribution grids?
I mean, it may be true to say that our focus on the electricity grid development is on carbon emission abatement and, of course, on security of supply. And we have observed a trade-off between biodiversity protection and climate change. For climate change, we need more investments in renewable production and henceforth also on grids, whilst for biodiversity, for sustainability, from this angle requires more protection and making sure that any investment we do is absolutely needed and addresses the impacts on the ground and minimizes any harm done there. This is also linked to public acceptance, and we know that grids investments are often at the heart of the different debates with the population because of the impacts on the ground, because of the impacts on biodiversity, and also indirectly then climate change. So we need to find the right balance between sustainability and climate abatement, and we need to be sure that we scrutinize every project for these impacts to make sure that we invest where necessary, but not too much. So it is without saying that we must look at all emissions, not only coming from production, but also from the grids, and life cycle analysis here is key. Just a couple of words then on the policy we have on infrastructure, so the Trans-European Energy Network policy. Here, the deployment of smart grids is one of the priority areas that we want to strengthen, and with intelligence, with digitalization, with automation, we may indeed be able to bring all the resources from production to consumption without unnecessary development of grids. So it will certainly have an impact on the optimization on where to build more grids and where to look for intelligent solutions instead. But smart grids is not all. Every energy grid project need to be smart, be it on transmission or be it on distribution level. So here we rely on the system operators and the other stakeholders to bring their intelligence to all the projects we are speaking about. And last comment here on the need to continue working on research. Digitalization, data, interaction with distributed renewables, electric cars will require that the system operators, in particular at the local level, be in the forefront of innovation and transforming our energy system. So from our research program, we are investing more than $1 billion in the period 2014-2020 on making our grids more intelligent and henceforth also more sustainable. So here we trust that the grid operators will come with all the necessary innovation solutions to look at emissions, losses, sustainability. One last point here. It is also important that the national regulators, when approving investments, also take into account the life cycle analysis and the impacts on the best technology, or what are the emissions, what are the losses, so that we also start looking at the full scale of both benefits and costs of all grid projects.
Thank you very much, Mrs. Sikow-Magny, for your insights. Now we return to our session. I'd like to start with Frederic Godemel from Schneider Electric. Frederic, how are you reducing the distribution grid's environmental footprint today?
Well, look, let's start by what we did at Schneider. We took sustainability as a key objective with our own sustainability index 15 years ago, so long-term program in order to be able to reduce our carbon impact, right? And we now move into a program that is aligned with the Sustainable Development Goals of the United Nations that we implement end-to-end in our factory. So the first thing we did was looking at the carbon footprint of our products. And the way we help DSO today is providing products who have a much better carbon footprint. I could mention the solution based on air to replace SF6 on all our medium voltage offer, so that we help now DSO to be able to integrate products that are much more environmental friendly and with a carbon footprint that is much better. But obviously that's not enough, because we know that the grid is evolving, so we help as well a lot to reduce losses on the network, because the energy that is lost is an energy that can be saved at the point of generation, and each time we save at the point of generation, this has a huge impact on the entire chain.
How do you expect things to change in the next 5 to 10 years? What sort of specific actions should DSOs plan for sustainability in their distribution grids?
Well, look, when you look at sustainability, you need to look at it end to end. Supplier, your own business, right, and your consumers. So the next big thing is obviously to implement with consumers solutions that help them to reduce energy, to reduce their CO2 footprint. Obviously, this will go a lot with a lot of more usage of electricity, as paradoxal as it can be, because electricity is the best source of decarbonization that we have available today. And because of that, it will need to ensure that between DSOs and their consumers, there is a real dialogue based on data, basically, to be able to optimize the CO2 footprint of this part of the chain. So products, distribution and consumer, we need to be able in the next 5 to 10 years to look at the entire chain and optimize the exchange of data around CO2 emissions, so that people can see basically very easily what is their CO2 footprint of tomorrow and how they can become carbon neutral. Today that's a big topic for all companies, and those companies are users of electricity. Most companies have today a plan to become carbon neutral, and we need to help them, and DSO have a key role to play there.
Thanks for that perspective. Now I'd like to put a question to the MEPs in our panel today. So how can the DSOs and the policy community work together to achieve Fit for 55?
Thank you very much for inviting me to this panel. Actually, DSOs have a very big responsibility for making sure that the necessary grid connections are completed in time in order to be able to meet our renewable goals. But I would like to stress that we are looking a lot at the large grid expansion in order to connect the offshore wind capacity to the grid, but we should pay more attention to the lower grid levels. There has been a study by the Deutsches Institut für Wirtschaft, which was published yesterday, showing that by strengthening the lower levels, we could actually lower the total cost, because we transfer the responsibility for balancing the grid to lower levels. At the same time, we are bringing more possibilities to the citizens, and it's my very firm belief that we will not be able to achieve this transition without taking our citizens along. And acceptance is fueled by participation. So we need to make sure that everyone who wants to put solar panels on their roof, who wants to set up a wind park together with their neighbors, who wants to found an energy community, has the possibility to do so. This is enshrined in European law already in the Clean Energy Package, and we should make sure that the grid is ready to take up the decentralized renewable production. And therefore, I would like to have a closer view also by policymakers, also in the Commission, on which what policy measures do we have to take in order to enable this, in order to strengthen the lower grid levels, and also how do we have maybe to change energy market rules, because right now the final consumer is paying for all grid levels regardless where his or her electricity comes from. And furthermore, for example, if you have a coal power plant in Poland and the consumer is an industry in, let's say, Italy, then the net cost, the cost for the grid are not paid by the Italian consumer completely, because there is no allocation of the grid enforcement which is necessary in Germany and Austria in order to transfer the electricity to Italy. I think this is a serious flaw which should be remedied in our policy, and I would be very curious to know what Commission is thinking on this. So as a final word, let's empower the citizens. They need to be part of the transition. We will not achieve our climate goals without them.
So thank you very much for that vision, Mrs. Paulus. If we could move to Mr. Grudler, could you please offer your perspective on this?
Yeah, thank you very much. The first thing I believe is that the DSOs and the policy community have to work together in the future. One thing that I have found to be particularly difficult to assess when working on the report on energy system integration was the level of investment that is actually needed on the grids to achieve our 2030 and 2050 targets. This is especially true for distribution grids. So the first thing that we need as policymakers is a better estimate of how much we actually need in terms of investments in the next 10 years. We need to be able to rely on accurate data. I recognize that this is a massive challenge for system operators at all levels. It is an equation with many unknowns, even at the micro level. How do we predict how many electric vehicles and how many heat pumps will be bought in a neighborhood? And how do we anticipate such changes and adapt the distribution grids to it? Additionally, I do believe that the European Parliament has a role to play in the shift towards a more decentralized vision of our energy systems. I personally want this legislative package to be an opportunity to close the gap that we still see maybe between EU policies on the transmission level and EU policies at the distribution level. We need to do as much for distribution as we have done for transmission.
Thank you, Mr. Grudler. To close this discussion, we would like to show how innovation supports DSO decarbonization. Let's hear from Stefan Luca, SF6 free leader for Schneider Electric.
A lot of companies are going for more and more sustainability program. It is becoming a reality that we are all turning into sustainable ambitions, right? So if you look after the company program, the company strategy, in which we're saying that we want to be carbon neutral by 2050, the idea behind it is to say, how do we apply our sustainable strategy to the medium voltage equipment we are manufacturing? How do we apply this strategy to ensure that our products tomorrow will be able to better enter in circular economy? So the whole program for a lot of companies are becoming more and more green. This is what we are doing here in Grenoble in our research and development laboratories to ensure that this product tomorrow will enter in sustainability. Why removing the SF6 from our equipment? We can see that Kyoto Protocol, for example, has already been listing some gases that are having a global warming potential. We can see the regulators in Europe will surely start to think on how to go into a sustainable trajectory for all our companies. We can see in China, the utility is already saying I have two specifications. One specification where I use the SF6 and another one where I don't use the SF6 gas. So the challenge we've been given here to our guys from the laboratories is to say, guys, we need to find an alternative to go into a more sustainable trajectory, taking example of what's happening either on regulation in Europe or in other countries. Some customers also asking us to go for a greener solution. But when we say so, we say we don't want to go for an alternative just for the bit of not using SF6. We want to go for something which is giving safety to our customers. We want to give the same customer experience. We want to ensure that whatever we are proposing as an alternative to the SF6 will be safe for the operators. Operators will be able to use it in healthy condition, and we are of course acting on the global warming potential, but we are also taking care of the operators and on the people who will use our equipment. So alternative to SF6, yes. This is why in our case we've decided to go with ambient air and pure air. So when I talk about pure air to be used in our equipment instead of SF6, we are extremely happy to say that this is already a solution that we have. We've already energized, we already use on this equipment with air instead of SF6 with some of our customers. I could easily talk about E.ON, I could talk about ENGIE, I could talk about Greenalp, that are customers that are using our new equipment with the air instead of the SF6 inside. SMR7 is a powerful green technology. What is making SMR7 green? I could easily say innovation is in the air. Green because we are replacing the SF6 by pure air. Green because we ensure that the full product is entering in a circular economy program. Green because whatever we can recycle in the product is recycled. So for all these reasons, we can easily say that when we say innovation is in the air, is because this air is turning our equipment greener.
Before hearing from our panelists, let's watch this testimony from Enel. Take a look.
L'incremento delle fonti rinnovabili è un obiettivo comune a molte nazioni del mondo. In Italia questo è già la realtà oggi. Io sono Cristian Noce, lavoro in Enel e mi occupo di Innovative Network Technology. Enel Distribuzione ha circa 32 milioni di clienti in Italia. The Advanced Distribution Management System è un componente essenziale delle smart grid future perché permette una migliore visibilità della rete elettrica. È possibile integrare meglio le fonti rinnovabili con tutti i benefici della green energy e inoltre incrementare la qualità del servizio e la qualità dell'attenzione. Questo prodotto era sicuramente il migliore sul mercato e negli anni abbiamo lavorato congiuntamente con Schneider Electric per migliorarlo ulteriormente. Che grazie all'utilizzo del Distribution Management System è in grado potenzialmente di ridurre le perdite tecniche per circa 144 gigawattora l'anno, equivalenti all'energia consumata da circa 50.000 case italiane in un anno stesso.
How DSOs will revolutionize operational efficiency. We know that the right investments in a grid for the future include efficiency, which directly affects affordability. Let's hear from our guests about how DSOs can increase operational efficiency, optimize asset management, practice circularity, and how planning and operations will converge for the benefit of everyone. So if I could start with the DSO perspective, Mr. Cammisecra, in your experience, what kind of technologies and innovations are making the biggest difference in operational efficiency today?
I honestly don't think there is one single technology that will visibly make the difference in the quest for additional efficiency. I think the the best of the efficiency will be kept by integrating the digital solution, the reinforcement of the grid, the let's say expansion of the grid in an integrated way. And in the case of Enel, also by sharing the cost of those technologies on the largest possible number of customers, using common solutions for the multiple grids that we do operate around the world. So I think the most important thing is to be able to create a platform approach, which means we will use all the technologies at every part of the grid, from the meters, the digital meters, going upwards in the secondary and primary substations, in the concentrators, along the lines, and in the dispatching centers in an harmonic way. So if we are able to do that, we can spread the cost of the technology in a very uniform and efficient way on the very large number of customers that we are serving already today, so that the efficiency will create synergies among technologies and will be spread over a very large number of customers, because we are building this platform approach where our solutions are independent by the specific distribution company, but actually are serving with the same scope and the same spirit whenever we are any possible client. But then let me add one thing. There is a crucial part of efficiency that I think we have to pursue, which is related to the choice of the customers, of consumers, to decide to use electricity for the energy needs. Because the massive volume of investments and the massive volume of, let's say, operational activity that we'll have to put in place in order to modernize and expand the grid to be ready for the energy transition will be synergetic with the higher volume of electricity consumed by the decarbonized consumers, and so this will create a larger base on which to spread the unavoidable additional investments that we will have to realize in the coming years. So I think this goes in two ways: platform from one side, orchestrating the technology all together, but on the same time try to use this huge investment base to serve more and more customers, consuming more and more electricity for the energy needs. I think the combination of these two things will basically make very marginal or ideally negative the impact on the final tariff for the final consumer.
Thank you for that. Mrs. Laigneau, what's your vision for operational efficiency at its best? You know, say 10 years from now, what do you need to make that happen?
I think, I think you're right, and we need to project ourselves in, let's say, I don't know if it's 10 years. For a company like Enedis, we issued a company project for the coming 5 years, and I think the question of the efficiency, operational efficiency, but also, as it has been mentioned, the ratio between tariff or price and quality you offered, because you can offer a high level of quality but at very expensive price, is key. So we need to work on our operational efficiency by being more agile, but maybe simpler for our clients. Sometimes distribution companies are quite complex because they have a technical approach. We need to put the client at the center of our concerns and make his life most easier we can. And within Enedis, we are working on that. It's about process, it's about IT, it's about tools, but it's also about people and training and how we need to recruit new talents and train them and motivate them and integrate them in our companies. So for me, the question of efficiency is very much focused on the issue of the price and the quality. We need also to pay attention to fuel poverty, because we are not investing billions of euros for ourselves. We are doing that for our clients, for the customers, at the end for the society we are living in. And this encourages us to pay attention to fuel poverty, to low incomes revenue people, and the data can provide some help in order to have let's say, an inclusive energy transition. Let's give some examples. By using the data collected by our smart meters, we can focus renovation, thermic renovation operations on buildings, on houses, on plants that requires the most to be, let's say, renewed. Because we can expose data showing that these plants, this building, these schools is not consuming properly. So being efficient means, of course, being competitive, attractive for industrial clients by the couple I've just mentioned, price and quality, but it means also pay attention to social cohesion, because I think we are responsible DSOs. We want a sustainable energy transitions, so we have to pay attention also to our, to all our clients. So, of course, it's not only a question of technology, it has been said, it's also a question of responsibility, of better use the data we have, and also keeping in mind that yes, we are not suppliers, we are not producers, we are DSOs, but we have clients and we need to provide them new solutions, maybe through platforms, as it has been mentioned by Enel, in order to be more agile and to be time to market, because the future addresses huge challenges, but I think we are ready and committed for that.
Very much. Thank you very much for that vision. Mr. Moulin, I know you have a depth and breadth of experience across transmission and distribution. What's your perspective on operational efficiency?
So I think one of the key elements here that we have proven with some of our customers that's going to be more prevalent is how we build adaptive network management solution for our DSO customers to help them in parallel as building a new infrastructure to actually increase the speed of getting more DR connected to the DSO grid without changing the infrastructure. Because infrastructure will have a longer lag time than actually what the society would like the DR to penetrate. And this is where our active network management allows you to be clear to the developers. You can increase maybe 50 to 100% DR penetration, but maybe you're going to be available on connected to the grid 98%, because we need to manage the dynamics of this connectability. And this is where I think it was also mentioned as flexibility. I would argue it's flexibility and dynamics, and those are the solutions we're bringing to the table to help fasten this rate of adoption of DRU in parallel with, of course, the infrastructure build, because we have this EV in addition to behind-the-meter solar that's going to come and impact the distribution grid, and we believe the power to X emerging technologies are going to be key also in this landscape. The other point I wanted to make is how artificial intelligence and machine learning are going to be needed tomorrow. Because we are in a transition from a very deterministic world to a more probabilistic or stochastic world. Because as you get to more a growing number of elements on the grid is going to be, and some of them are not necessarily dispatchable, you're going to get into this transition. That's going to be a key aspect. And here we believe that as this uncertainty factor grows and some elements become hard to measure, AI and ML will allow to unlock the value of the data, as long as it will have a real interest if we can loop it back to the operational or asset needs to increase the efficiency. And this is where you could increase the efficiency of your T&D contingency analysis schemes, also to your T&D inertia, not only measurement but forecasting. Or another example is the vegetation management, how you can make that more efficient. So because we believe that the ability to learn from historical events to predict future operational needs is critical, but at least as importantly, the capability to refine the forecast as they get confronted to new events to the point made earlier, I think, by Marianne, more events happen on climate. So we need those machine learning elements to help us learn from each new event to refine the forecast and be more precise and gain operational efficiency as we learn along the way. This is also linked to the need to be more flexible in the approach. So this is where I believe, as a technology provider, we can help the DSOs, who in the end are the one operating the networks, not us. We're just solution providers, and we can help them and be the partners to having this evolution path together.
Thank you very much, Mr. Moulin. Mr. Godemel, having heard our guest's perspective, would you like to offer your view on the topic of operational efficiency?
Yeah, I will offer maybe a bit of disruptive view and shocking view, but efficiency, what is required from us as a profession is to be more efficient than the previous solutions that were existing, right? That means so that we can offer to consumers benefit from this efficiency. I will take the example of the mobility, private mobility, that we are now in the process of electrifying, right? Look the efficiency of the previous chain. Oil was extracted mostly not in Europe, transported, refined in Europe, distributed through gas station and petrol station, where people had to go there and pay with their own card. Our goal is to be more efficient with electric vehicle than this previous industry. I believe it's something that we can achieve. Why? Because generation of the energy will be much more local. Distributing this energy will be much, much cheaper than the previous chain I was explaining. Invoicing these services is something that DSOs and retailers know how to do at a cost that is extremely cheap. Right? All this will benefit to the consumer, in addition of decarbonizing our environment. That's where the efficiency resides. If we are able to bring this efficiency in a greener world to the consumer, and with, I believe, a scale of efficiency thanks to data, because we will be able to exchange data between renewable production, distribution, and usage, we will be able to put the user inside this equation. By doing that, I believe technologies will allow investment that is rational and that benefit to the user. So I believe just by this example, we understand that yes, we need to invest into the world of electricity, but the benefit for the society is extremely significant.
Thank you everyone very much for the fruitful, interesting exchanges today, and have an excellent Power Summit.
Thank you, Ed.
Thank you and goodbye.
Thank you.
Thank you, goodbye.
Thank you, bye-bye.